Okay, so in this video we're going to solve the 1990 Calculus AB. Question number 4, it's a related rates question. So it says the radius r of a sphere is increasing at a constant rate of 0.04 centimeters per second. So right now let's label that. dr over dt is going to equal 0.04 cm per second. And it gives you the volume for volume for a sphere, which is v equals 4/3 pi r cubed, whatever. So now it says at the time when the radius of the sphere is 10 centimeters, what is the rate of change of increase of its volume? So what you're going to do over here is you're going to have v equals 4/3 pi r cubed. You're going to take the derivative, so now you're going to get dv dt, because that's what it wants to know, equals 4 pi r squared dr dt. You're going to plug in, so you're going to get 4 pi, 10 squared is 100, times 0.04. So when you do this, it's going to become 4. 4 times 4 pi is 16 pi centimeters cubed per second. So you should write a sentence and say, when the radius is 10 centimeters, the rate of change of volume is increasing by 16 pi centimeters cubed per second. Okay. The next part of our question says, at the time when the volume of the sphere is 36 pi cubic centimeters, what is the rate of increase of the area? Okay, so 36 pi is the volume, equals 4/3 pi r cubed. Divide by 4, you're going to get 9. Multiply by 3, you're going to get 27. Divide by pi, you're just going to get 27, equals r to the third. So r has to equal 3. Okay, so now we know area of a circle is pi r squared. So now we're going to get dA over dt equals 2 pi r dr dt. And now you could plug in, so you're going to get 2 pi times 3, because that's what we got before, times 0.4. So now you're going to get 6 times that is 0.24 pi centimeters squared per second, because it's area. Then you would say a sentence, when the radius is, or when the volume is 36 pi, the area is increasing at a rate of 0.24 pi centimeters squared per second. Now, part C says, at the time when the volume of the radius of the sphere are increasing at the same numerical rate. So what we have to do over here is we need to write down at the time when the volume and the radius of the sphere are increasing at the same numerical rate. Okay, so dv dt needs to equal dr dt, because it's saying both rates are the same. So dv dt is this over here. That part right there. Let me draw an arrow just in case. So we're going to plug that in right there. So we have 4 pi r squared dr dt equals dr dt. So we want to solve for r. We're going to divide both sides by dr dt. So now we're going to get 4 pi r squared equals 1. R squared equals 1 over 4 pi. You're now going to take the square root of both sides. So you're going to get 1, the root of 4 is 2, root of pi is don't know, don't really care, cm. Okay, I hope this video helped.